We're going to continue our discussion into like terms today. And I'm a card player. I like playing with cards. And so if I was dealt a hand here and I had 1, 2, 3, 4, 5, 6, 7, 8 cards dealt to me, and I want to know the number of, say, hearts, I would not do it this way. 1, 2, 3, 4, 5, 6, 7, 8. 8 hearts. Because we know that's not correct. Because if I'm going to write an expression about the 8 cards I was dealt here, we'd count the hearts. 1, 2, 3, 4, 5. And we would count the diamonds separate. 1, 2, 3, because they're the same thing. These are like terms. So if I wanted to write an algebraic expression about this, and I used H for hearts and D for diamonds, I could write 1H plus 2H plus 3H plus 4. So I could end up with 5 hearts. And what else do I have? I have 3 diamonds. Again, we don't count straight up, all right? And these are like terms. And this is the way we think about like terms. We look at the variable in algebra to decide what are like terms. And when we have a single variable, it's usually pretty easy. So if we do an example of that, I have 3 x's in a pile, and I add 2 more x's in the pile. I had 3, I add 2, boom, I have 5. And again, we're adding coefficients. The variable matches, and we add 3 plus 2, and we get 5x, because this symbol is positive. If I have 6x minus x, which is 1x, 6 minus 1 would be 5x also. Again, just using the integers. We think of this as 6 plus negative 1. But here we go back to this example. 3x plus 2x is 5x. Is that correct? Well, we can check it. Down here I said let x equal 4. And if you want to do a check on expressions, be sure not to pick 0 or 1, because weird things happen then. So I put in 4 over here, and if I plug in 4, I get 20. If I plug 4 into 5x, I get 20. And again, it checks out. We can always add by deciding what the terms are. So here's another very long expression. 1, 2, 3, 4, 5, 6 terms. First thing I do when I have a problem like this is identify which ones are the same. And I'm going to start with, do I have any other x's? Plus 4y, no. Plus 6x, yes. Negative 8y, no. Negative 8, negative 3, no. Well, then I have plus 4y. So I mark the plus 4y. And I have negative 8y. I mark the negative 8y. Negative 8, negative 3, not the same. Negative 8 and negative 3 are both values, so they are like terms. Now I've marked them all. Now I just have to do the combinations. 2x plus 6x. Well, 2 plus 6 is 8 x's. Plus 4y minus 8y. 4 minus 8, how about negative 4 y's? And then both to the left, negative 8, negative 3, negative 11. And we've simplified this 6-term expression to a 3-term expression. Again, by picking out the like terms. Now, when there's multiple variables, we need to be aware of something. 3xp plus 4px. When we look at this, we have to realize that you can multiply in any order. 2 times 7 is 14. 7 times 2 is 14. So I will start by writing all my algebraic variables in alphabetical order. It just makes my life easy. And is px and px the exact same? They are. So 3 plus 4, I could call this 7px. So again, let's try a couple of examples of that. Up here I have a 5-term expression. And my first step I'm going to do is I'm going to write it in alphabetical order by term. So negative 2xy is still in order. 3x has just the one variable. Minus 4, and instead of yx, I can multiply in any order. I'm going to call it xy. Plus 7 minus 6x. I'm going to see what like terms there are for xy. Negative 2xy. 3x is not the same, because x by itself is not the same as x times y. But here's x times y again. Negative 4, looking left for sign. 7 and negative 6x not the same. I see here I have the positive 3x and the negative 6x. So again, I have a 5-term expression that I'm going to be able to simplify to 3 terms when we're done. Negative 2xy plus a negative 4xy. xy stays the same because we're counting them. Negative 2, negative 4. How about negative 6xy? Positive 3x, subtract 6x, negative 3x. And then the 7, like the math teacher, has no friends, so it just hangs out at the end. My last example for the day, again, has multiple variables, and we have to get them in order and decide which ones are alike. Now, a lot of students are able to see that these two are alike. That's great. Be careful. Sometimes they set you up to see if you're really paying attention. But the first thing I'm going to do, as we learn, is write each term in alphabetical order. Because by doing that, I think it becomes very easy to see that this is ACY, ACY. And AC is not the same as ACY. 3 plus 6, I can write 9 ACYs minus 2AC. Now, it's important to note, you can write this another way. This is the same as negative 2AC, looking left, plus 9 ACY. Or it could be negative 2CA plus 9 CAY, or any order here is fine of each term. And again, up here I could have written negative 3x first. The order of the terms is not important as long as the signs looking left are correct. Again, like terms, the key is to look at the variables and make sure they all match.